All right, hi Math 2. This first video is to go over the solutions, okay? So 478, I heard from about 5 of you who said, you have no idea what's going on 478. Well, these speed distance questions always tend to be a little bit tricky. So this is actually, believe it or not, whoops, sorry. Okay, this is actually a blast from the past in disguise. So here's what I want you to, I just follow my pen here, all right? So you were told the current speed is 1 kilometer per hour, but I'm calling it the people speed. The people speed is unknown, okay? So what that means is that on day 1, when they are going, I think they're going against the current, right? The people speed is knocked down by 1 kilometer per hour, right? The units here are kilometers per hour, okay? And on day 2, the people speed is helped by the current. So that's why the speed is x minus 1 on one day and x plus 1 on the other day, okay? Now here's what's important. The total time that they took for the whole trip, you're told, is 6 2/3 hours. I think it said 6 hours, 40 minutes, right? Okay, we have to convert to the right unit. So if they gave you 6 hours, 40 minutes, and our problem here is in terms of hours, we've got to convert to the correct hours. So 6 hours and 40 minutes is 6 2/3 hours, or 20/3 hours, okay? So here's the first line here, all about time 1. So on day 1, excuse me. So on day 1, right? Oh my goodness. On day 1, this is their speed, and their time on day 1, let's just call it y, because we don't know what the time per day is. So the time on day 1 is y. The time on day 2 is going to be 20/3 minus y, right? Because the total is 20/3. So I just have this, right? Now, the distance they travel on day 1 is 7, and the distance they travel on day 2 is 7. So those distances were the same. Okay, well, I just made a couple notes here. I said, remember this equation, speed times time equals distance, and I wrote distance on day 1 equals distance on day 2, okay? And then what I have here is speed times time equals distance. Note the parentheses. Here's day 1's equation, if you will, all right? Here's day 2's equation. Speed times time equals distance. It's right here. And we've got a system, right? Now I'm going to do a substitution. I'm going to solve the top equation for y. I could have solved the bottom equation for y, or the top equation for x, or the bottom for x, but if you look at the 2 equations here, it's set up so easy to solve the first equation for y. So here's the first equation for y. And then I substituted y in for y in the second equation, and I got this. Now here's where we're going to pause, okay? This is where things get new. So I just want to reiterate, everything up until here, this point, this was all old news. Granted, it was a little bit trickier. It was like a trickier version of the kind of rate times time questions, right? So, but the idea is kind of the same. Is rate times time equals distance. We set up a system, we have substitution. Now, look at the yellow box. Here is where things get new. Now, when you look at this equation right here, right, hopefully you're noticing a couple of things. You're noticing, oh, I've got x in the denominators. And this is we call them, I think your book called them fraction equations. I called them rational equations. And there are a number of things you could have done at this point. You could have taken this whole x plus 1 and certainly distribute like that if you wanted to. That's fine, okay? What I did is I just divided both sides of the equation by x plus 1, because then it's looking to me like something we just very recently worked on. Right? We have a fraction rational equation, a rational equation. Okay, I'm going to start using rational equation. I think that the phrase in your book, fraction equations, is just kind of dumb. I'm looking at this equation and I notice the LCD is this, 3 times x minus 1 times x plus 1. And now we're kind of like in recent old news. All of this has to get distributed. Boom, right? And when you after you distribute and after you cancel the common factors, we land here. And then from here, folks, it's just a matter of just plotting your way through. But then something else interesting happens. If you multiply everything correctly, oh, ho, 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 what's here? Get out of town. A quadratic equation. So in one problem, everyone, we have a speed times time equals distance problem, which is tricky already. We have a rational equation. And then we kind of morph into, remember, like this is like Ben turning into Sophia, right? It morphs into a quadratic equation. Look at that. And, oh my goodness, what's even more unbelievable is when you factor the left-hand side, you know, it's like a look for the GCF first. It makes your life easier for the GCF. And then we've got a factorable. Look at that. And at the end of the day, you get the club speed or the people speed equaling -2/5 or 5/2. Obviously, we don't have negative speed. So we just found the club speed, 2.5 kilometers per hour. Now, I think they asked you how long would it take if there was no current. So all we did was, you know, we used the speed times time equals distance. And I just did distance divided by speed, and you get your time. All right. That was definitely, not only was it a tricky speed times time equals distance question, this question incorporated a lot into one question. All right. All right. 506. Option 1, option 2. This is the job thing. A couple of ways you can go about this. Maybe some of you, you know, figured out how much you made on each day, starting at day 1, and you kind of saw that at some point option 2 gets bigger. I just jumped right to day 31, right? On day 31, right, I make this amount. Now, for option 2, you had to have created this equation right here, right? Because now, here's the thing. If you're doubling your amount in pennies every day, right? Doubling means you're increasing by what, everyone? If you're doubling, you're increasing by, listen to my words, if you're doubling, you're increasing by 100%. So notice here, the base here is actually 2, which is 200%, right? 100% growth added to the 100% of kind of like equilibrium, okay? And I just found that on day 31, I make this many cents, but ones in cents, ones in dollars, another unit conversion here. And I just converted the cents to dollars, and look at that. On day 31, you make about $21 million. And on day 31, you make 31,000 in option 1. So to me, that's a dead giveaway that option 2 is better. And then finally, 508 over here. 508. I don't think that part A caused any issue, and I don't think that C caused any issue. Let's just talk out B and C for a second, okay? So what I'm going to do here is I'm going to focus up here on this exponent, right? And you see, this is B is one you can actually figure out. Log of 1,000 is 3. And then when you raise 10 to the third, you get 1,000 back, right? That one you can actually just do methodically. But then D, right, we're going to move towards here being able to do question D without a calculator. So I want you to think about this. If you figure out what log 4.8 is, right, this number right here is the exponent that you would raise 10 to get 4.8. It's not going to be a nice clean integer, but if this number right up here is the exponent that 10 is raised to get you 4.8, well, if this number is the exponent that 10 is raised to get to 4.8, and then you raise 10 to that very exponent that 10 is raised to give you 4.8, what you get back is 4.8. And ladies and gentlemen, what we have here is a second property of logs, which says, I'm going to write it out for you here. It says, if you have some base, I'm going to call it B, okay? And if you raise B to the power of log, now this is important, of that same base B, I'm going to call it, let's call it A, all right? Because here, unwritten but understood, this is a log base 10, right? This is a log base 10. If you have B raised to the power of log base B of A, the end of the day, what is the answer? What does it simplify to? It simplifies to just A. All right. All right. Second video is going to come up, and that's going to be the lesson for today.